So let's go through this sharp right. For number 1, you needed to solve the equation to distribute on both sides. And then after you distribute, you can combine your like terms on both sides. So on this side we have 5x and negative x. On this side we have 6 and negative 30. And then from that point we can start moving things. What did someone move first? The 2. Okay. So by adding it, we have 6x plus 18 equals negative 28. If that is not the way you did that and you started some other way, that's fine. Remember, there are 4 different ways you could solve these. But since, say that again.
For the minus 30, and that's a positive 6, right?
Yes.
So wouldn't it be negative 24?
Yes, that's what I meant. Thank you. Why not? But since we moved the 2 over to the left, we have to move our constant over to the right. So by subtracting 18. Is that right? Yeah. Okay. I'm like doing mental math and not doing it correctly. So x would have been negative 7. Questions on that one? For number 2, we needed to put negative 4 in for x and figure out what that is. So that would be 2 times negative 4 to the second power plus 10 times negative 4. You could either put this all in your calculator or in Desmos or solve it algebraically. Simplify it algebraically is what I meant. So this would be 2 times 16 minus 40. 2 times 16 is 32. So this would give us a negative 8. So you could put f of x equals negative 8 or f of negative 4 equals negative 8. Either of those work. Questions on that one? For number 3, 6 less than a number would be some variable minus 6. And then on the back, we have another solving one, and then we have absolute value. I was going to say inequality, but that's not what that is. So for this one, distribute. If you noticed it after you distribute it, that these have the same coefficient and different constants, you could have stopped there, said that these were no solution. If you didn't see that and kept going, if I add 8x to both sides, they both cancel, and I'm left with negative 8 equals negative 2, which does not equal. For number 5, we would have needed to isolate the absolute value signs first, so get rid of the 3 by subtracting. I did not do that correctly. 30 is what that should have been. However, we cannot solve absolute value equations that equal a negative, so this would have no solution. So if you continue to solve that, that was incorrect. Questions on either of those? Those of you that have your computers, you don't need them right now, so you can close them, put them away so they don't distract you. Take out your notes from last class, the graphing notes. And turn to this page. Everyone have those notes? If you need another one, I have extras in the dark blue crate. Look for the graphing folder, and there's some in there. About how to just graph lines from slope-intercept form, from standard form. Today we're going to talk about a couple other different ways to solve, to graph. One is by intercepts. So on the test, or not any of the Khan Academies, I think part of the Delta Math, it might ask you to graph by intercepts instead of slope-intercept or standard form. It will, or converting from standard form. It will be in standard form in order to do this. What we are not doing is solving this or finding our slope and y-intercept. This is kind of the same thing as when we were finding intercepts from the equation, like on Khan Academy and some of the other examples we did in class. These blanks are cover up the y term, solve for x, cover up the x term, solve for y. So the cover up is putting 0 in. So if I put 0 in for y, this becomes 0. So it's like this entire term disappears, which is why I can set ax equal to c. Same thing for the other one. If I put 0 in for x, this entire thing becomes 0, and it's like it disappears. Which is why I can set by equal to c. So think that in your mind, that's what we're still doing, putting 0 in for x or y, solving for the other part, but we're not actually doing that. So that's technically what we're doing, but we're not actually going to do that part, yes. So if we're using literally just this, I'm going to cover up one of these terms and see what's left. Negative 2y equals negative 6. Solve for y by dividing both sides. Positive 3 is what that should be. Then I can plot that point. That is just the ordered pair 0, 3. So I would plot that point on my y-axis. For my x term, I would cover up the middle term and see what's left, which would be 3x equals negative 6. I would solve for x. And then plot that point. In this, because we have 2 points, we can make a line. So from your x and your y-intercept, you're going to connect those two and just make a line. You're done. So this would be a different way to graph. Not by slope-intercept, not by converting standard to slope-intercept, but just by graphing the intercepts. I'm finding the x-intercept, the y-intercept, and I'm graphing both points. Do we have any questions there? Let's do a couple more, then I'll let you try the remaining. For number 3, I don't remember this one. Yes, for number 3, when I cover up one term and set it equal, there's nothing in front of the x or the y, so what happens is this just becomes x equals 3, or the ordered pair 3, 0. And same thing for y, except 0, 3. So I could plot both of those points and draw the line in between them, or through them. For number 5, same thing. I could cover up the y term, see what's left, 4x equals negative 4, and solve. Divide both sides by 4. So that would be the point negative 1, 0. And then when I do the same thing to find my y term, I have negative y equals negative 4. So I would need to divide both sides by a negative 1. So that would give me the ordered pair 0, 4. So up here. And once you have those 2 points, you can make your line. So this method only works if it's in standard form and it doesn't tell you to specifically convert to slope-intercept form. If it tells you to convert to slope-intercept form, then this method doesn't work. Do we have any questions on this process or this method? I want you to take the next 5 or so minutes and do the other 3. And then we'll go over them. Okay. Number 2, your intercepts were at 4, 0, and 0, 2, making your line negative. 4, your intercepts were at negative 5, 0, and 0, 4, making your line positive. And 6, your intercepts were at 5, 0, and 0, 3, making your line negative. Do we have questions on any of those? So that's like a simpler way to graph them without, I mean, you're still graphing your y-intercept either way, but without graphing all of your slope points. What I don't want you to do is like do both. Either graph it using just your x and y intercepts, so that's just 2 points. And I would say if you're graphing it that way and it doesn't specifically say how to graph it, tell me that you're graphing it by x and y intercepts. Or graph it by converting it and show all of your slope points and y-intercepts. One of those two, but don't mix them together. On the next page, somewhere on there, I want you to rewrite this. I know we've written this before, but I want you to rewrite it. And we mentioned this before, but I'm just going to mention it again. Toy bucks is horizontal lines that have a 0 slope and are y equals equations. And then vertical lines that have an undefined slope and are x equal equations. Are you okay? So when graphing these lines, you're going to be given some equation, a y equals some number or an x equals some number, and that will tell you whether the line will be horizontal or vertical and what type of slope it should have. So for number 7, and I know the graphs are like kind of blurry, so try your best. This is a y equals equation. So will this be a vertical or a horizontal line?
Horizontal.
Horizontal for number 7. So what you're going to do is on your y-axis, find where y is negative 5. You can put a point there. And then you're going to make a horizontal line at that point. I'm going to actually change this color so you can see it a little bit better. And that would be it. This type of line would have a 0 slope, and it would just be a horizontal line. If you flip that and made it a vertical line at -5, what would happen is here at -5, if you made it a vertical line, that would include other numbers. So your y wouldn't just be at -5, and that would actually be an x equation, not a y. For number 8, would this be a vertical or a horizontal line? Vertical at -1. So on your x-axis, find when x is -1. Put a point there, and you're going to draw a vertical up and down line. Yes, Javier.
So for that, the horizontal, why don't we put it on the 0?
Why don't we put
Like,
it like right
or
here?
the 9, yeah.
Because y doesn't equal -5 there. So we have to find where y equals -5. So on your y-axis, and draw a line like this. Do 9 and 10 really quickly. I'll give you 1 minute. You should have a vertical line for number 9 and a horizontal line, but mine's crooked, at 10. Do we have questions on how to graph horizontal or vertical lines? And then here are some that relate back to these, but also slope questions. You can use your grpahs if you need to. What would the slope of y equals 5 be?
Horizontal?
That would be a horizontal line, but the slope would be 0, yes. Okay, what would the slope of x equals -2 be? Undefined. What about the slope of x equals 0? Yes, it's a trick question because they throw in that 0, but it's still an x equals, so it's still undefined. We're going to graph both of these, and then we're going to talk about the differences and similarities. Does not matter which one you do, but which one you do where, but I'm going to do y equals 3 here and y equals 3x here. So take a second, go ahead and draw both of those graphs. So I'm not going to write these down, but you may want to write some of these reasons down, just to kind of help you remember which one is which. Again, my line for y equals 3 is a little crooked because I can't, well, I guess I could have just drawn it. I can do that too. It will probably be even more crooked, but we'll see. Let's see. Stop that. Okay. So what are some differences and or similarities that you see between these two? Javier?
The y equals 3 is completely straight horizontal. That
Straight
one goes
horizontal.
on a slope.
What did you say about the other one?
That one goes on like a slope of vertical slope.
It's like a diagonal. Okay. So one's horizontal, one's diagonal. Other similarities and or differences? Saeed, did you have one? Okay. There are others. Okay. The first one has a slope of 0.
Not first, but y equals
This one.
that's
This one has a slope of 0, and this one actually has a numerical slope. I mean, that one technically does too, but I understand what you meant. The slopes are different. Any other differences?
I have a question. What's the slope of that layer? What is it going by?
3.
3?
3 over 1 each time.
Okay.
Did you have your hand raised? Okay. Do they both have an x and a y intercept? No. They both have a y intercept. They both don't have an x intercept. This one has an x intercept. This one does not. 3 in the problem, yes. If this were x equals 3, they would both have an x-intercept, but not a y-intercept. So those are some differences to think about when you are graphing those. If it has an x, it's going to have a diagonal slope either this way or this way. If it does not have an x, or it's just an x equals a number, it's going to be horizontal or vertical. Say that one more time. So your y-intercept is what? Oh. Your slope equals 30. What's your y-intercept? 0. So we would start at 0 and then use your slope and go up 3, right 1, up 3, right 1, or go down 3, left 1, down 3, left 1. Do you have any other questions on this? I'm going to give you guys until about, what time is it right now? 9:22. 32. Almost till about 9:40 to do the next page, front and back. So you have examples where you need to convert, find the intersection graph, horizontal and vertical lines. These don't have words to tell you what to do. Thank you. So you can pick and choose either convert or do intercepts, and then this one says vertical and horizontal. So I want you to go through those. I know some of you have started those already or did those already. If you did those already, go ahead and move to the very last page, which I don't think I have on here. Oh yeah, I do. The practice page. But you're either working on this front and back, or you're working on the very last page, depending on if you work ahead or not. So 13 through 16, if those are the correct numbers, I don't know, I may have renumbered them. Whatever those first four are, you needed to convert them to slope-intercept. So those equations were, and I can outline these lines just in case you can't see them. Y equals 4x plus 7. Y equals negative x plus 2. Y equals negative 3x minus 4. And y equals 1/2 x. Yes.
For the top one, number 16, or
Yes, the numbers are different, but which?
Then 14 for that one.
This one?
No, for.
Oh, for this one, okay.
Does that say y equals negative x?
Negative x.
Plus 2? Can you show me how you got that?
So they would. You have to solve this for y, so you would subtract x to the other side. And then switch these two. Or you could have switched them at the beginning. Other questions on those four? For the ones by x and y intercepts, your x-intercept was at 2. Your y-intercept was at negative 4. And then there's a line going through them. For the next one, your x-intercept was at 1. And your y-intercept was at negative 3. For these bottom two, you should have had a vertical line at 7 and a horizontal line at negative 2. And then I think these are converting, but if you did them by intercepts, that's fine too. Or maybe I did them by intercepts. Yeah, so if you did them by converting, that's fine. If you have questions on those ones, just let me know and I can convert whichever one. If you did them by intercepts, this one had intercepts of 1 and 5, so you had a negative line. This one had intercepts of negative 4 and 2, so you had a positive line. This one had intercepts of 1 and negative 1, so you had a positive line. This one had intercepts at negative 3 and 1, so you have a positive line. Did anyone do those four by converting and need to see the equation for any of those? For these four, you should have had a horizontal line, a vertical line, another vertical line, and then a horizontal line. Let me write this. 46. Do we have questions on any of these, or need me to go back to any? So the there are 2 that are due on Friday. Many of you have already started those 2 because they were really on what we did last class. If you have not done those 2, it's the graphing from slope intercept form and the graphing from standard form, linear standard form. For the remainder of class, sorry, my mask is hurting my ears. What you guys are going to be working on are one of these things, or multiple things. First, I would say focus on the Khan Academies and Delta Math. If you did not do those 2 Khan Academies that we worked on after class last time, you can start those. Work on the Delta Math. That is due Wednesday. If you've already done those 3 things, you can work on this practice, the last paper in the notes. If you've already done all 4 of those things, check in with me and you can work on other schoolwork. If you've not done one of those 4 things, you should be working on one of those 4. Questions on what we're doing for the last little bit of class? You guys have this time to work?